Okay, hey, we're gonna go over the test. I'll put this on announcements too. I'll be giving your test grades, the comments about your test back to you. Um, but be sure to go over this. You can see what I do here in answering these questions and compare it to how you answered them. Okay, so let's start with question one. Sorry, I have to look off here and read it here. 3x plus 7 equals 1. 3x plus 7 equals 1. Okay, maybe the most straightforward kind of problem there is. So subtract 7 from both sides. I talked about this a lot. Well, here's what I didn't write down. You can. It's your choice. I know I keep saying that, but it is. So you could write down, minus 7, minus 7. You make the call. You don't have to at all. Divide both sides by 3. 6 divided by 3 is 2. Okay. So, and I think everybody got that one right. I'm trying to remember, but okay. Let's see. Number 2, 2x minus 3. Oh, sorry, 2 times 4x minus 3. Whoa, I can't even read my own typing here. 2 times 4x minus 3. Let's see, equals 3. Okay, our good old friend, the distributive rule. This times this, this times this. Let's add 6 to both sides. So we'll add, right? Negative 6 plus 6 is 0. It's gone. So let's add 6 to both sides. And divide both sides by 8. Okay? All right. First two out of the way. Now, let's see. Number 3. 3 halves times 6x minus 8 equals 1/3. Okay, so now we get some fractions into the game. And, well, it's sort of mixed results here. But at any rate, hey, this times this, this times this, this times this. Now, from here on out, I'm not just, look, if I said what's 4 times 5, 20, no one wants to see how you did that. We assume, yes, you know how to multiply it. Yes, you're good at it. Yes, you're really good at it. So we don't want to talk about it. And we don't want to talk about it when it comes to fractions. You can show your work. I mean, of course you can talk about it. But at any rate, this times this, the numbers are pretty nice there. So 9x minus, same thing here, 12 equals 1/3. Let's add 12 to both sides. So 1/3 plus 12, 37/3. And we'll divide both sides by 9. 37 divided by 27. I could tell sometimes by the way people write things that some people, they didn't feel confident in this answer because maybe the number looks quote unquote weird. The answer is what it is, and numbers are just numbers. There's nothing particularly strange about that. Okay. Now on to problem 4. Problem 4, let's see, 4 brackets. Remember, brackets and parentheses mean the same thing. So if you don't like the brackets, use parentheses. If you don't like the parentheses, use brackets. Okay, 3 plus 2. And where am I at here? Wow, it's going to be tricky to read all this stuff here. What? Oh, 5x minus 1. Equals 7. Okay, there's multiple ways to do this one. When there are parentheses inside of parentheses, I tend to work from the inside out. You don't have to, but I think that's easier. I see the distributive rule. We love the distributive rule. We do the distributive rule whenever possible, even if we don't know why. Get that? We also love combining like terms. So I see 3 minus 2. Now I could have done this distributive rule, and that's fine. No problems. You'll still get the same answer. You still get the correct answer. But I can't resist. Look, 3 minus 2 is 1. That's combining like terms. And now good old distributive rule. Let's subtract 4 from both sides and divide both sides by 40. Not too bad. Not too bad. Okay, next problem. Next problem. That was number That was number 4. Let's do number 5. Let's do 1/2 plus 3. I can't remember things for 2 seconds now. 3 plus 4x. And minus 3/5. 2x minus 4. X minus 1. Okay. Well, what to do? Distributive rules there to be done, so let's do it. This times this. 1/2 times 4. Kind of nice. This times this. Careful. It's negative. Right? So negative 6/5 x, and then again, be careful. Negative 3/5 times negative 4. Negative times a negative is a positive. So plus 12/5 equals x minus 1. Let's combine like terms. Where are like terms here? 2x minus 6/5, 4/5 x. 3/2 plus 12/5, 27/10. Let's get the x's on the left and the numbers on the right. So we'll subtract 1x from both sides, and we'll subtract 27/10 from both sides. And I'll go ahead and write that down. You don't have to write all this stuff down. The real deal is you should write down what you feel is helpful for you to write down. Okay, so minus x equals negative 1 minus 27/10. Whether you want to write this line down or not, it's a tough call. But okay, so negative 1/5 x, 4/5 minus 1 is negative 1/5, equals, and then over here, negative 37/10. I'm going to divide by negative 1/5. How do we divide? We flip and multiply. A negative times a negative is a positive, so our answer in this particular case is positive. We get a little bit of canceling going on here, so negative 37/2. So this is the answer. Well, nice problem. Distributive rule, combine like terms, got to deal with fractions. I like it. Okay. Next problem. Next problem. That was number. What was that? That was number 5. Oh, 6. Yeah, one of my favorite types here. Number 6. So, problem number 6. Taking track of that. Divided by 3 plus negative 2, 1 minus 2x divided by 5 equals x over 2 minus 1. Okay. One of my favorites. Why? There's a lot of work to do. And you demonstrate that you have all the skills in place that you need to have in place to move on ahead. What first? I would say distributive rule because it just jumps out at me. It's there. Distributive rule's there. Let's go ahead and do it. This times this, this times this, this times this, this times this. So we get 6x minus 4 divided by 3 plus negative 2 plus 4x divided by 5 equals. I'm going to rewrite this. You don't have to, but I am. Why? I think most of the time, not all the time, most of the time, it's probably preferable if you do this. But I want to make sure that yeah, I'm still recording. Okay, great. Sorry, I'm flipping back and forth on these screens there. Okay, what next? There's a 1 under here, there's a 1 under here. How do we divide? We flip and multiply. Why am I going to change multiplication to division? Because in general, if you gave me a choice today, would you rather do division or multiplication? I'd rather do multiplication. So let me write this as multiplication. So 1/3. And then here. Distributive rule. Why? Because they're to be done. So let's go ahead and do that. So 2x minus 4/3 minus 2/5 plus 4/5 x. And this is just all the regular, ordinary stuff that we do a lot of. Combine like terms, because we like to combine like terms when it's possible. So there's like terms right there. 2 plus 4/5, 14/5 x, negative 4/3 minus 2/5. Negative 26/15 equals 1/2 x minus 1. Let's get the x's on this side and the numbers on this side. I'll subtract 1/2 x from both sides. Remember, regular, ordinary, subtraction. So on this side, I'll have 14/5 minus 1/2. 14/5 minus 1/2, and that'll be 23/10. And on that side, I'm going to add this to both sides. So I'll have 26/15 minus 1. 26/15 minus 1, so what would that be? 11/15. And now we'll flip and multiply. So what would x equals? What will x equal? I'm going to flip this and multiply. So we will have 11/15 times 10 over 23. We get some nice cancellation there. So x equals, what do we wind up with? 22 over 69. So there we go. Really nice problem. Again, I was happy to see a lot of you got it right. It's great, fantastic. Some of you did it a different way. But as long as you got the right answer, that's okay with me. I didn't specify or say how you had to do it. Okay, so there's number 6. Obviously, one of the longer, more complex problems that you had to deal with on the test. Number 7, what happens was 2? Oh, it's similar. It's very, in fact, it's extremely similar. It's really the same type as the one we just did. This number 7, I'm going to put a note up here. I'm going to forget which one we're doing. Number 7. 1/2 x plus 2, all divided by 2, plus, or minus 3 times 3x plus 1. Over 5 equals 3x minus 3. Wow, same, very similar type. It's a little bit, it's only different in fact. But one of these factors out here is a fraction. I like basically trying to force people to do these because it's just fantastic practice for all your skills. Let's do the distributive rule, 1/2 x plus 1 all over 2. Same thing here. Now, notice the way I'm going to write this, and be careful with the positive and negative signs. I could have written minus. Absolutely, I could have done that. And maybe I'll regret doing that. But this times this, negative 9x, and this times this, negative 3 over 5 equals 3x minus 3. Let's write this as multiplication, just like we did with the last problem. Nothing new to be said here. Do the distributive rule. Oops. Again, nothing new here. Very similar to last time. Combine like terms. Let's see, 1/4 minus 9/5. Whew. Even me, sometimes my brain just goes on strike. I mean, it doesn't want to do this, but you have to force yourself to do it. Just have to do it. So when you get this here, negative 31 over 20x, and then 1/2 minus 3/5 would be what? Negative 1/10 equals 3x minus 3. Tell you what, let's get the x's on the right. Now, you can get them on the left. That's fine. A-okay, no problems. Why would I do that? Because I noticed that I'll have 3x plus this. So I'll have a positive quantity of x, and I'm going to add 3 to both sides. And since 3 is greater than 1/10, 3 minus 1/10 is positive. It'll make everything positive. You don't have to, I know, but it just seemed a little bit easier this time. So we'll have 3x plus this. So that'll be 91 over 20x. Again, numbers like that seem to check people's confidence. And to get that whole idea. But let's add 3 to both sides. So 3 minus 1/10 is 29/10. Let's do the old flip and multiply. So x is here 29 over 10 times 20 over 91. That goes in there once, that goes in there twice. And x is equal to 2 times 29 is what? 58. And over 91. So there we go for that problem. Nice, juicy, meaty problem. A lot of work to do. Fantastic. I was happy to see a lot of people got it right, all the way right, not even a Carol's mistake. Certainly not everybody got it right, but it's, at the end of this life, it's to be expected. Okay, number 8. Solve for t. Now, we're going to have a little breather here, not so bad, 3t plus 4x. So this is number 8. Oh wait, there's number 9. Hey, I'll do number 9, and I'll come back to number 8, just because I already got it halfway written down. So number 9 equals 3r. And the instructions were solve for t. Solve, we're going to get t by itself. Let's subtract 4x from both sides. Barking dog in the background. Divide both sides by 3. Done. There's other ways you can write this. Hey, let me just point this out. This is correct. How do you divide by 3? You multiply by the reciprocal. That's correct. I could have done the distributive rule. This times this times this. And I could come up with some other ways to write it, but these I would say, as far as normal, quote unquote, regular ways to write it, I would say this and this. Looking at it, this is actually a little bit nicer down here, but this is perfectly acceptable, and this is correct too. Okay, so that's number 9. Not too bad. Not much in the way of calculations there to be done. So now let me do number 8. A equals 1/2 times th. I'm always curious what I was thinking when I wrote this down, th. And we're supposed to solve this for h. So how do we get h by itself? We want to divide both sides by all this. How do we divide? We flip and multiply. Hey, I could have written it like this. Watch this. 1 times t, 2 times 1, 2, h. How do we get rid of all this quantity right here? This factor right there. Divide. How do we divide? Flip and multiply. So we'll have 2 over t times a equals h. I would normally write it like this, h on the left. You don't have to. And not only that, I probably wouldn't leave it like this. It looks a little odd like that. I would probably say 2a over t, because there's a 1 under there. How do you multiply fractions? You multiply straight across the top, straight across the bottom. So there's an answer. There's certainly other ways you could write it. You could write it like this: t over t times a, 2 over t times a. You could write it like a times 2 over t. You could write it like a over t, or 2 out in front like that. I mean, you could write it a whole bunch of different ways, and they're all acceptable. Next problem. Let's see. That was number 8. I already did number 9. Let's do number 10. Here's number 10. 3x, that's inequality. Okay, 3x plus 2 times 4 minus 3x is less than something. 7. Okay. Let's multiply this out. 3x plus 8 minus 6x is less than 7. Combine like terms. 3x minus 6x, negative 3x. Let's go ahead and subtract 8 from both sides. Negative 1. Divide both sides by negative 3. Watch out. If you multiply or divide both sides of an inequality by a negative number, you have to switch the sign. So x is greater than 1/3. That's an acceptable way to leave the answer. You could have graphed it like this, 1/3, your choice. Or like this, 1/3 with a hollow dot. Or in interval notation, 1/3, like that. There's other ways to write it too. We could use what's called set builder notation, but hey, we'll just leave it at this. Any one of those is acceptable. I did not say how you had to state your answer, so however you wrote your answer, it is correct. That was fine with me. Okay, number 11. Number 11, solve for x. Number 11. 5x is greater than 5x. Now, if you were sort of on your game or on your toes or thinking, you would look at that and immediately know, how could that be? How could anything be greater than itself? And it can't. But let me proceed to try to solve this. Let's say I just didn't notice that. How about if I subtract 5x from both sides? If I subtract 5x from both sides, I would get 0 is greater than 0, and 0 is not greater than 0. So the answer is no solution. You can also write it like this, which is the empty set. You could also write it like this. It's pretty odd, but you could do it like this. Except don't do it like that. Hold on a second. Oops. I mean, pick a number of your choice. That would be all real numbers. Just the opposite in the solution. I suppose. Pick a number, any number. Okay, 8. I don't care. 13. I don't care. 72. Because this would represent all the numbers greater than 72 and less than 72, but not including 72. And there aren't any, so that's empty. That would be a really odd way of writing it. On the other hand, look at this problem right here. You could have divided both sides by 5, and you would have had x is greater than x, and that should have struck you as being somewhat odd. I guess you could divide both sides by x and get 1 is greater than 1. No matter how you slice it, the original statement, inequality statement, is something which is never true. So there's no solution. No solution. Okay. Pretty easy one. Test of logic. The next one, 4x plus 3. The next one, compound inequality. Two inequalities together. 4x plus 3 is greater than 2x minus 1. And I connected these with and, the word and. 7x minus 4 is less than 2. So again, when we have a compound inequality, we just solve these separately. So let's go ahead and do that. How about let's subtract 2x from both sides, subtract 3 from both sides, divide both sides by 2. Numbers are so nice here, it's catching me off guard. The and comes down along for the right. Let's add 4 to both sides. 7x is less than 6. Divide both sides by 7. X is less than 6/7. My favorite way to do this is to make a graph and consider both of these solution sets. This is x is greater than -2. There's -2. So it's everything going off in this direction. I'll mark here. So everything going off in this direction. And then x is less than 6/7. So say 6/7, that'd be everything going in this direction. And our solution set, because it's and, we need all the numbers that satisfy this and this simultaneously. So the solution set is everything in the middle. You also could write it like this, maybe a little more neatly than this graphing business. I would tend to do this. I don't tend to write these graphs. I would tend to use interval notation like this. Okay, so but either way is fine. Wow, I don't want to bring this up. I suppose technically, if you wrote this and this, I guess that's technically right. So if I marked it wrong for you, you could point it out to me, and I guess I'll give it to you right. Writing it like this or this, it checks to see that you understand the logic of the word and. We need this and this to be true at the same time. Okay. Next problem, which was another compound inequality, but now connected by or. So this is number 13. Number 13, 4x minus 3 is less than 2x minus 1. Or 7x minus 4 is less than 2. We'll solve each of these separately. Let's add 3 to both sides and subtract 2x from both sides. Was this the problem I just did a minute ago? I'm not sure. The numbers look similar. Oh well, I can take a look at it. Make sure I got the right numbers here. 4. I just changed signs a little bit here. That's why it looks similar. Got it. Subtract 2x from both sides, we get this. Let's add 3 to both sides, we get this. Or, and over on this side, why don't I just finish this off? X is less than 1. Over here, let's add 4 to both sides. 7x is less than 6. Divide both sides by 7. 6/7. These are connected by or. So we need all the numbers. Use some different colors here. X is less than 1. Here's 1. Those are all the numbers less than 1. 6/7 is less than 1. So here's all the numbers less than 6/7. But we're connecting these with or. So we just need numbers that work in at least one of these. So we take all the solutions for both and combine them together in one set. And that would be all the numbers less than 1. Or we could write it like this. I'd probably prefer to write it like this, but this is fine. Okay, that was number 13. Onwards to number 14. How many questions were on this test? 25. Not bad. I should have asked all of you how long it took you to do it, and you could have done some statistics. Average time it took people to get through the test, etc., etc. Okay. Let's see, 14 through 18, graph the equation. Make sure to show the intercepts. Find y equals 3x minus 1. Since you have to show the intercepts, here's what I usually do, and I did point this out before, but I usually I don't know if I make a table of values, but just to show you what I'm doing here. Here's x, here's y, x is 0, y is 0. Why would I always set my chart up this way? Because this right here will give me the y-intercept, and this will give me the x-intercept. If I put a 0 in for x, we get -1. If I put a 0 in for y, you have to do a little bit of work, right? 0 is y, right there. 3x minus 1. How about we add 1 to both sides and divide by 3? So x is 1/3. So there's our intercept. So 0, -1, -1. I don't want to get lazy. Let me write it correctly here. 0, -1. That's this point right here, which is the y-intercept. And here, 1/3, 0. So over 1/3, 0, 1/3, 0. And there's the straight line. What did I say? Did I say, please state the slope of the line? Y equals mx plus b, so the slope here is 3. And you could have, if you made it on, some of you made it on graph paper, or if we'll start graphing things, like I said, on something like Desmos, and you can just, in this case here, it would be easy because you'd see every time you go over 1 block, you go 3 blocks. All right, so that's, what number was that? That was number 14. Now 15. 15, 3y minus 2x equals 5. Make sure it's right, 3y minus 2x equals 5. I'm going to do something that I pointed out before that you don't have to do, but I do. And I think I'm only saying I think it's a good thing to do. It's certainly not necessary, but it's maybe not a bad thing to do. Write this in the form of y equals mx plus b. So let's add 2x to both sides. And divide both sides by 3. Now, of course, you can see right away the slope here is 2/3 and the y-intercept is going to be 5/3. And I could have done that last time instead of making that chart over here. So here's the y-intercept. Let's call it right here, 0, 5/3. To get the x-intercept, I have to put a 0 in for y. So 0 is equal to 2/3 x plus 5/3. -2/3 x. This is hopefully very straightforward here. So x is, you notice when you flip and multiply, the 3's are going to cancel each other out. So we're going to get -5/2. So call it right about there. There's the point, -5/2, -2.5, 0, right there. And there's the line. And again, the slope is -2/3. So that's number 15. Okay, number 16, 3 times 2x minus 1. If you found this a tad annoying, fair enough, I agree. Let's flip sides and do the distributive rule. Why? Because I like doing the distributive rule. Divide both sides by 4. You didn't have to do that, but what I did again is I put it in the form of y equals mx plus b. I can tell the slope. The slope is 3/2. The y-intercept is 4/3. Let's make a graph. -4/3 right here. 0, -4/3. There's the y-intercept. To get the x-intercept, we got to make y equals 0. 3/2 x minus 4/3. 3/2 x equals 4/3. X equals 8/9. So out here somewhere, call it right about there. 8/9, 0. Again, these arrows you don't have to put. And if I put them if it's not clear which ordered pair or which point this ordered pair refers to. Okay, so there's that one. And number 17. Number 17 is y equals 3. Now that's the special case. It's a horizontal line because it has the form y equals mx plus b. It's just m is 0. Slope is 0, horizontal line. So we can make a graph of this pretty easily, although sometimes it gets tricky to see. Maybe I better use a different color. 1, 2, 3. There we go. There's the line. There's the y-intercept, 0, 3, right there. There is no x-intercept. If you try putting a 0 in for y, you would get 0 equals 3, which it can't happen. I mean, that's never true. So there is no x-intercept. And the slope is 0. So you just say slope equals 0. And that bothers some people, but no reason to be bothered. Okay. This means every time you go over, you don't go up or down. Okay, the next one I think is the special case. Next problem is number 18. So this is number 18, and the problem was x equals 3. If you have x equals a number, that's the special case where it's a vertical line. Let me just go ahead and do it. The vertical line, 1, 2, 3, and there it is. The x-intercept, 3, 0. There's no y-intercept, and there's no slope, or we say that the slope is undefined. Because if you think about this for a second, slope is rise over run. Any 2 points on this line, the run will always be 0, and you can't divide by 0. So no slope, or you can say slope is undefined. Now, number 19. State in your own words the relationship between a graph and the equation which determines it. Basically, like I said before in one of the previous videos, the relationship between a graph and, did I say relationship? Yeah, I could have said function, I guess, in this case, but is that every point on the graph is a solution for the equation, and every solution for the equation is a point on the graph. So any version of that was fine. Now, 20 through 24. Let's see, determine the graph of the line which contains the given pair of points. So the first one, 3, 4, 5, 10. I didn't say you had to make a graph, but I think it's a good idea. But you didn't have to, and I didn't say that at all. I didn't say you had to. And 5, 10. So 1, 2, 3, 4, 5, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I can tell, you don't have to make a graph, but I can tell that I wouldn't trust, I have the line chopping here, but without doubt, the slope is positive. How do you find slope? You subtract the y coordinates and then subtract the x coordinates. So that's 6 divided by 2, otherwise known as 3. Sounds reasonable. So y equals mx plus b. Let's pick a point, because every point on the line has to be a solution for the equation. So we can pick either point, it's your call. I'll pick this. Y is 4, x is 3. Put a 4 in there, x is 3. Just a coincidence, those two are 3's. That's 9. Subtract 9 from both sides. B equals -5. So let's wrap it up. 3x minus 5. And there's the solution for that. Let's go ahead and I'll go ahead and do them all. Gosh, they're all, I think the remainder here are all going to be the same, or at least the way you do them will be the same. The next one, 3, 4, 2, -1. 3, 4, and 2, -1. If I make a super quick graph here, 1, 2, 3, 1, 2, 3, 4, right there. 2, -1. So again, it certainly looks like it has a positive slope. Subtract the y's. Be careful, watch. 4 minus -1. Don't lose track of that. You subtract the y coordinates, and this y coordinate is -1, so 4 minus -1. And then we subtract the x coordinates, 3 minus 2, so that's 5 divided by 1, and that's 5. So y equals mx plus b, mx plus b. Remember, when I hear the word line, or read the word line, L-I-N-E, line, as soon as I read or hear it, I think of y equals mx plus b, compulsively, habitually, can't help it. Blah, 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 line, y equals mx plus b. What's b? Let's take a point here. I'll take the first one. The y coordinate is 4. The x coordinate is 3. That's 15. Subtract 15 from both sides, and we'll get -11. So y equals 5x minus 11. Okay, so that was number 21. That was number 21. Almost to the finish line. 22. Number 22, let's see. Oh, I threw in some fractions. Good for me. 1/2, 1/3. And what was the other point? 1 negative 2/3. 1 negative 2/3. So again, we can make a quick graph of this. 1/2, 1/3, call it there. 1 negative 2/3 down here. So this is going to have a negative slope. But now to get the actual numbers, let's go ahead and use the infamous, famous, whatever it is, slope formula. So subtract the y coordinates. So 1/3 minus negative 2/3 and 1/2 minus 1. Remember, it doesn't matter which order you subtract them as long as you're consistent. So if you take this y minus this y, it has to be this x minus this x. Or you could take this y minus this y and this x minus this x. You'll get the same answer. Go ahead and try it. I did it in one of the videos and showed you why that's the case. But at any rate here, remember when you subtract the negative, they really become a positive. Whoa, they already have a common denominator. Oh, maybe I made this to come out nice. I looked at this and I thought, wow, that comes out is 1. And the odds of that happening by random chance are pretty negligible. That 1/2 minus 1 is negative 1/2. And of course, well, I said I wouldn't talk anymore about how you do fractions, but how you divide, you flip and multiply. So this is negative 2. So y equals negative 2x plus b. And let's take one of the points. Probably it seemed like most people gravitated towards this because I like the whole number there. But there's y. So negative 2/3 equals negative 2 times 1 plus b. What do we have here? Negative 2. Here, let's add 2 to both sides. So we have 2 minus 2/3 equals b. And what does that give us? 4/3. So b equals 4/3. So we'll put it all together. Y equals negative 2x plus 4/3. You know, if you made a graph, particularly, like I said, if you went to Desmos and made a graph, plotted those 2 points right there, it would look like the graph crosses through, you know, a little bit above 1. It may not be clear that it's 1/3 above 1, but it's definitely between 1 and 2. Okay, that was number 22. How about number 23? Number 23. 3, 5, 4, 5. Aha, okay. 3, 5, 4, 5. So let me get a quick graph of this. 1, 2, 3. 1, 2, 3, 4, 5. 4, 5 is a horizontal line. So we could go through that whole same procedure at the same time. Y equals mx plus b, but it's a horizontal line. It's obvious from the graph. So the slope is 0, and the y-intercept is obviously 5. So we're done. Like I said, we could go through the exact same process I did for the previous 2 problems, and you'd wind up with the same thing. You'd wind up with a slope of 0. You know, look, 5 minus 5 is 0. 4 minus 3 is 1. 0 divided by 1 is 0. You wind up with the same thing. Okay. Next problem. I can almost anticipate what it's going to be, but 4, 4, 0, well, I would have been wrong. So 4, 4, 0, 0. 4, 4, and 0, 0. Let's make a quick graph of this. There's 0, 0. It's the origin. 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. And that's not only a nice line, it's like the quintessentially super uber epically nice line. This line even has a name. I like to call it sort of like the line with a capital T, but it's really called the identity function. We don't have to worry about that, but it's a really nice line. Why? If someone said pick a line, any line, it'd be tempting to pick a horizontal line. In fact, it'd be tempting to pick the x-axis. But you might say, well, it's kind of a special case. You know, how often is the slope exactly equal to 0? So if someone said to you, pick a slope, any slope, but don't make the slope 0, I'd probably make the slope 1. And that's the slope of this. And we'll see that in a second. And, you know, it's pretty reasonable to make the line go through the origin. But at any rate, this is a very, very, very nice line. So y equals mx plus b. What's the slope? 0 minus 4 divided by 0 minus 4. Flip those around. That's 1. So y equals 1x plus b. Hey, let's take this point for fun here. 0 equals 0 plus b, so b equals 0, so y equals x. And for those of you who take quite a few more math classes, or even a few more, you'll see that this is one of our go-to examples for a lot of different things. So this becomes like a friend eventually. Or I think of certain things as animals in the zoo. Oh, that's a tiger, that's a penguin. And you know this when you see it, y equals x. And that's what it looks like. It's a straight line, slope is 1. It does happen to form a 45-degree angle here with the horizontal. And it slices through the origin. So very, very nice. Straight line. Okay. Is this the last question? Yes. Graph y is less than. So here, now in this one, I asked you to make a graph. 3 times 2x minus 5. And minus 7. Let's go ahead and do the distributive rule and combine like terms. Let's tidy this up or straighten this up a little bit here. So you don't have to, but come on, it's gonna make things a lot nicer. Minus 7. So y is less than 6x minus 22. Okay. I said, because 22, it means the y-intercept is 22, so I need to get 22 incorporated into the graph in terms of the scale of the drawing. Let's go down here to negative 22. You don't have to make this, we don't have to make it, you're trying to make it to scale, you don't have to, and the picture doesn't have to look beautiful, but there's negative 22. Hey, it's definitely below the origin, because it's negative. The slope is 6, so every time you go over 1, you go up 6. So it looks like this. But the key thing we're getting at here is that we're looking for all ordered pairs x and y that satisfy this inequality. And to do that, y would have to be less than the corresponding value you get when you substitute a value for x in there. Whew, that was a lot of words. Here's the solution. It's everything below that line. And this should be dashed because it's strictly less than. If it was less than or equal to, we'd leave it as a solid line. But it's dashed. Okay, so I don't care how you shade it. Shade any way you want. Shade it with a nice color if you want. Okay, so there's the exam. We're going to go into chapter 5. So the next video will be a chapter 5 video, and that will be coming later today. All right, let me get to the off button here. All right.